Any questions about the last slides? If you remember, we looked at this. So what I can do is I can run through a quick overview of what we covered the last day. And then if you have any questions or observations, please, you can shout out or put them in the chat. But this information processing cycle is very important and it's central to everything we're talking about. Because what it does is it gives us a way of pulling in everything together when we're talking about information. And you've always got this movement from data across to information. But because data, I suppose it's a bunch of stuff, it's a bunch of facts and numbers and figures and words and things, but we need to do things to it to get insights. So we're always after insights to guide us. So we want information to help us guide our decisions. And your main stages are your input, your processing, which is how you handle the data, your storage, and your output. So what we're going to look at today is these two, data storage and data processing. So the last day we looked at data input. So how do we collect the data? How do we get it into our digital system? Please know this information processing cycle, and understand this and know the parts. You've got in, you've got out, and in the middle, you've got processing and storage. So this is super important because this pulls everything together that we're talking about. So talking about input, which is the first one here. On the way in, and you've got sensors, you've got barcodes, you've got web analytics, you've got EDI. We went through all these. We went through the different components that you might have in a smartphone or in a home gaming setup, this camera system. Then we moved on to barcodes, some of the uses that they have in business. And why do businesses use barcodes? So when you go to the supermarket, why do they use barcodes? Why do they bother? I can't use
To keep records.
to keep records. Yes, very good. Exactly. To keep the records. When you think about it, when you go to the cashier in the supermarket and you're paying, it's much faster to use the barcode system than it is for the cashier to type in the price of the item. So have you ever been in an old store, it's maybe a smaller shop, where the cashier has to actually type in the price? Or maybe the price is on the item. They've gone around and they've put stickers on the item, and then the cashier looks at the item. So those type of old stores. And then essentially what the cashier has is a calculator rather than a kind of a till system. They use a calculator. So would a calculator work in a bigger store? So if you had a big store, would it be possible to use a calculator?
Yes, but it will be more complicated.
It would be a lot more complicated. And look, stores tend to use look, it says it down here, improves accuracy, speed, traceability, because also those barcoded systems are linked to the stock management. Every time an item is sold, it goes -1 on the stock levels. So the businesses use them. So barcodes, look, an input technology, super convenient for businesses. So then we went and we looked at web analytics, what that was, how it worked, what it tracked, and maybe some high level points. Could anyone give me an example of a web analytics platform? We looked at one the last day. So what was the web analytics platform that we looked at? Can anyone Google Analytics? Exactly.
Yes.
And does anyone know how much it costs? Does it cost a lot or a little?
Different prices for different subscriptions.
Different, but Google Analytics itself is actually free. It's free. We looked at Gmail. That was a Google product. Google Analytics is free because they want you to use it. So because it helps Google search and it gives Google visibility as to all the traffic. So if you think of big data, so Google is collecting all the information about all these visitors to websites. It's also collecting information on all the searches that people type in into Google search. So when I go to a new page, when I go to this page, does it cost me?
No.
No.
No, no. So Google, the way they make their money is they monetize the data that they collect. So it's free for the users. So it's free for me now to type in carpenter near me, and it'll show me all the carpenters. So I want to get some work done on my house, where they are. So Google runs all this service for free, but the way they make money is they have visibility as to what everyone is doing. And then they say, see these ads, they're coming up as sponsored, sponsored, sponsored. That means that these people have paid to have their ad placed very high up in the search results. And that's Google's business model. But this is free. But again, they're just collecting your data. So yeah, Google Analytics, an example. There are lots of others as well. And most of them are not that expensive. And then we talked about SEO, how to optimize the page for a search engine, all the things you could do, and all the sort of the real world uses that website analytics have. And then the last one, EDI. So could anyone explain that to me in a simple way? So what happens with EDI? So say I'm here. So what do I do? Talk me through this. I send a automatic exchange. Automatic exchange. It means if I want to send you a file, I have to email it to you. I have to drag it from my desktop and push it across. But with this, the computer systems or the computer applications of these two businesses are connected. So when something happens over here, that document or information is pushed across. It's pushed across. And actually, usually in the middle, you would have a partner. You can have an EDI partner because sometimes you need to translate between the codes. Because I could have codes on my products in my business, and the other business could have slightly different codes, and you might need to adjust and translate between the two. A lot of the time, you have what they call an EDI partner. These are all EDI partners, and they would sit in between those businesses. So they would sit here, my business, EDI partner, the trading partner. Examples and benefits, we looked at those. There are lots of them to do with not having to manually handle the files. And then we moved on to data and that kind of understanding data, the different types of data, quantitative, which is numbers, qualitative, which is more words, and then we drifted into data validation. We'll look at a little bit more of this today, why it's important. And then we moved on to keeping our data safe. Two-factor authentication. I think you guys are pretty familiar with this, where you have a secondary device like a phone and it gets a signal or it gets a passcode sent to it and it keeps your data or your information safe. So these are all tools that modern businesses use. But think of what we looked at the start, the information processing cycle, and that was like fundamental, it really is to everything we're talking about. So we've looked at input devices. We've looked a little bit at how to keep our information safe. And now today, what we will do is we will look at storage and processing. So if you think of the four steps, we have input, processing and storage, and then output. Cloud computing. Remember, we're talking about storage here. Now, we touched on this briefly in the introductory lectures, but today we'll look at different types of storage because you can have on-premises storage, which is where you have a server or a database in the business, and you can have different types. But likely the most common storage that you guys will be used to is cloud storage or cloud computing, you'll have different variations of that businesses will use. So you might be familiar with the domestic product or the Gmail storage as opposed to the Google Web Services storage. So these are the type of packages that businesses and quite big businesses use. So we'll go through this. Please stop me if there's any questions, or you can pop them into the chat. So cloud computing is when programs, files, and data are stored on internet servers instead of a single computer. And these servers are located in data centers, and they're managed by the cloud service provider. So then some examples: AWS, Microsoft, Google Cloud. Some examples over here. And with cloud computing, users can log in from any device with an internet connection and get their information. And this means work can be done from home, school, anywhere else. And it also means you don't need to be on the same computer every time. You can just log in and grab your files, maybe using a browser. And cloud computing has grown really quickly because it allows people to store huge amounts of data, run powerful programs, and share resources, and right across the world. So it saves money for businesses because they don't need to buy expensive equipment and upgrade everyone's computer. Instead, the cloud service provider handles software updates, storage, and troubleshooting. And one of the major benefits of cloud computing is collaboration, where people in different places can work together in real time on the same document or project. Cloud computing has enabled remote work, fundamental to everything we do today. Now, we've looked at this already, so I won't dwell on it. So remember, we had three types. So we had a public cloud. Let me just highlight these. Public cloud, a private cloud, and a hybrid cloud. Public, private, and this is a kind of a combination of the two. A public cloud is managed by the service provider, and then the resources such as storage are owned by the provider and the customers pay for what they use. But on a public cloud, your data and other people's data will all be hosted together. You have different sort of storage buckets. Now, with a private cloud, it's used by a single business or organization, and that can be hosted internally or by a third party. And this model is preferred in industries with high security needs, banking, healthcare, government, those type of things. Now, a hybrid cloud is where it's segregated. So you have a mixture of public and private, and sensitive data then can be kept in the private cloud and the less critical information in the more public area. And look, there are benefits, flexibility, cost saving, etc. And then companies also use cloud-based intranets, and these are private networks for employees only, and they require staff to connect through a VPN. So a VPN is like a tunnel when working remotely. So do you understand this concept of the different cloud models or types?
Yes.
Public, private, and hybrid. Although cloud computing has many benefits, there are also important security considerations. Businesses and individuals can take multiple steps. These are the type of things you can do. So encryption ensures information is stored in coded form and only someone with the correct key can read it. So you can also take backups, and these are provided by, could anyone explain to me what's a backup? What's a backup?
Backing up your data is storing your data on another medium in order to protect if
Yeah.
your main data is lost.
Exactly. So for cloud providers, what they have is they might have the information in two locations in the cloud, and it could be two separate countries. Let's go in and have a look at some of so these, if we go in, let's just go into Google. So you can see Google, they have data centers in all these different locations. So what they might do, and I know there's a big one here in Ireland. So what they might do is they would keep a copy of your information here, but they might also have a backup copy over here or over here. And they wouldn't keep them beside each other because if something like an earthquake or a tsunami or like a big catastrophic sort of weather event was to happen, they want the data to be protected. So usually your backup, it's in multiple locations, but those locations, they're not necessarily beside each other. And it means you can recover it then if things go wrong. So another thing that can happen or you can use is strong passwords. And we looked at that again the last day. Do you guys use strong passwords?
Yes.
I try and begin to use strong passwords. So even things like, this. And these are these codes that you use. So let's just look at this. If your password, now this would be an AI password system. And what it would do, it would bomb your system with passwords. Now, some systems have a kind of a timeout function that if you put in the wrong password 3 times, it locks it down or something like that. But if your system didn't have that, these AI systems, so you really do need, and you can see this is the length of the password. So if my password is like this, which is very short, and it's just, see the way this is starting to go. So as I go down now, it's really telling me that's not a strong password. So what I need is I need more length and more complexity. I need a bunch of stuff in it. Now, as I go up, you'll see that it gets more and more complicated. Now it's telling me this is strong. So just be mindful. You can sometimes lose access. So really you want to be away from these sort of red blocks if possible. So what you're usually talking about is having your password in and around 12 characters. And like this would take a very long time. So these are uppercase and lowercase letters. You can see just by introducing numbers into the password, 2025 123 at the end of it, like it substantially increases. And remember, these are just estimates. What I would say is try to get into the habit of using strong passwords. Also, use two-factor authentication. And we looked at that the last day where you get the secondary code. Then these are all things that providers use. And these are steps that you can take to protect the data in the cloud. Also, connecting to public Wi-Fi networks. Do you guys use public Wi-Fi networks? Be careful when you're on these networks. And it's okay to use them, but I would use them more for browsing. There is a risk when you are logging into services. There's a technique called wiretapping. And basically somebody connected to the same network. So it's a little, what is wiretapping? Yeah, basically somebody connected to the same network can eavesdrop on your activities. So if you're putting in a password or something, like into a cloud service or a banking service, it can be grabbed if the person knows what they're doing. So just be mindful of them and only use them if you have to. And these will be big open networks like you get in train stations and those type of places. But look, cloud computing, it's already part of everyday life. I think you're all familiar with Gmail, Outlook, Google Docs, those type of things. You've all saved photos on iCloud, on Google Photos. You use these streaming platforms, Netflix, Spotify, Xbox Live, and all these examples are built on cloud computing and cloud services. And they all show that cloud has become central to all the things we do, our professional work, our personal life, and it's due to the convenience, flexibility, and efficiency that it offers. Any questions about cloud before we move on? I think you guys are pretty familiar with. So databases. So a database is a storage method or approach that a business is more likely to have. And when you think The cloud service providers, they're essentially databases in the cloud that people are managing on your behalf. But if you're a big business, you'll have your own database and you'll manage it in-house. So why do we use databases? So on its own, raw data is not useful. And to become meaningful, data has to be processed and organized so that it becomes information. So remember, we're moving from data to information all the time. And when information is analyzed, it creates knowledge that the business can use to make decisions. And databases play a central role in this process. And they provide structure so that vast amounts of data can be stored, organized, and retrieved. And without databases, businesses would be left with a bunch of scattered facts that wouldn't be able to guide decisions or actions. So in the past, data was often stored physically in address books, in paper files, in folders, in filing drawers, those type of things. And these methods helped keep information organized, but there were limits and limitations, and large data sets quickly became unmanageable. And finding specific details would take too much time. I know here in Ireland, say if you go to a hospital or a doctor, sometimes they have to go and retrieve a paper file based on your previous visits. So some parts of the health service are digitized, and then there's other parts that aren't. Part of the work I'm doing with the moment is I'm actually working with the health service here in Ireland to help get them ready for this digital transition and moving away from those more paper-based systems into databases and digital systems. And it's happening in lots of areas of business and government. And today, a lot of businesses use digital database. A digital database is a structured computer file so that can store, organize, and update information in ways that physical storage can't. And then examples would include Microsoft Access for smaller tasks, or then this is Microsoft Access, and then you would have larger scale systems, such as SQL Server, SQL Server, you'd have Azure, those type of things. But all the big cloud providers, they all offer database solutions. And these digital databases are super powerful because they combine structured storage with analytic tools, and they give the businesses the ability to process large data sets, large amounts of information, and make data-driven decisions, because you're trying to figure out the facts and then make the decisions based on those. So databases sit at the heart of nearly every business function. So any digital platform, and it could be a website, a mobile app, or a social media service, is built on databases that store and retrieve information in the background. And organizations use databases to manage customers, employees, products, sales, inventory, supply chains, everything. Data might be entered manually by staff, such as when recording, say, HR information, or collected automatically by technology. And we looked at some of that, how some of the input methods, such as inventory tracking or some sort of building management system where you could have sensors. Other examples, marketing teams rely heavily on databases, and they collect information about customer preferences, sales history, web activity, all that kind of stuff. So they're called CRM systems. You can also have public data sources such as census information, climate data sets, and these can be added to business databases to support strategy. And together, all these data inputs form the foundation for decisions that guide how organizations operate. Database, here's the database, and all the parts of the business, everything is connected to this. It's the information hub that everything runs through. Now you have data warehouses, which is a type of database, and a production database handles live business activities such as sales, customer orders, and inventory. But because these systems are in constant use, organizations, they often use separate databases for testing or for analysis. So you now don't have just one database, you have multiple databases based on the need. And large businesses often centralize their information in a data warehouse. And this integrates data from multiple sources. It pulls everything together and it stores it for long-term use. And a data mart is a smaller version of a data warehouse. So these are all different types of databases connected in different ways. The data mart allows access to information, and this it has to be carefully managed. And analysts often request data sets from a warehouse, download them securely, and then they use software such as Excel to explore the data, or they process it and they look at it to try and figure things out. In this way, data warehouses ensure that live systems remain available while still enabling decision makers to work with reliable and structured information. So these are all different types, as I said, of storage databases, all connected in different ways. And then we have RDMS, Relational Database Management Systems. So this, again, another variation. So the power of databases lies in their ability to connect information. And a relational database stores data in tables and it creates links or relationships between them. So this is a way, it's like a matrix, a way to link things together. For example, one table might hold customer details and another table might hold sales transactions. By linking the two, the analyst can establish and find which customers bought which products. So over here is customers, over here is sales, and your RDMS is the linkage in the middle. And this is managed through the RDMS and software, and it organizes, stores, and retrieves the data efficiently. And then these examples, they include MySQL, so these are all examples of commercial RDBMS software. In smaller businesses, Access is often used. So I'll show you. So this is Access. And it's like a smaller version of database software. These other examples would be bigger. And then relational databases support complex queries when you're looking at something, trying to find something, joins reports, and they make it possible to work with large data sets, and they are essential. So the last 4 or 5 slides, this is all to do with information storage and databases and the different types of databases that you might come across. So the next thing we're looking at are flat files. So flat files, you're probably more familiar with these. So these would be things like Excel files, these files that you host on a storage device like a hard disk, and then you work on them. Like a Word document would be a flat file. So you pull it from storage, you work on it, you save it back to storage. So not all data is stored in databases, and many organizations rely on flat files. And these are simple files that look like tables or spreadsheets. So flat files commonly contain rows for records and columns for fields, such as names, addresses, or sales figures. And they're easy to create and work well for small data sets where the user understands the structure. So you've got your columns and you've got your rows. You all know what a spreadsheet is? Let me just load. So this would be a spreadsheet program. So there's different variations. So this is Google Sheets. You've got your columns, right? And you've got your rows. And it's a grid system that you put your information in. So you can build out lists, and then you have different ways to add things. You have your functions, you can filter it, all that kind of stuff. So you can do all these type of things once you get the information in here, and then you can have multiple sheets and then you can link them all in different ways. So this is like a flat file in the cloud, because remember, this is running on the Google infrastructure because it's part of email. The Excel file, you can run it in the cloud in a browser, but you can also run it on a machine. Now, flat files are great. Lots of businesses, nearly everyone uses them, but they can be limited because they don't link to other files or other systems, not in the same way a big business would need, and they become difficult to manage as the data set grows. And what you can have as well in organizations is this thing, dark data, where it's like a file on a specific machine that only one person has access to, and that can be a limitation in the organization. But despite these drawbacks, flat files remain really common because they're straightforward to use, and you can just open them with everyday tools like Excel that lots of people are familiar with. Some uses then. So they're often used to transfer data between systems. So a CSV file, comma separated values. You grab a file from one system and then you import the file into the next system. And that allows you have two disconnected systems and the file goes between them. An example, a warehouse may export its inventory records into a flat file format. And these files, they're plain text, they're widely supported, and it makes them ideal for moving data between different business systems. If you think of an Excel workbook usually has lots of tabs down here, doesn't it? Now, with a CSV file, when you download it, it's just usually a single sheet. So you don't usually have multiple tabs. In an Excel workbook, you probably do. But so CSV is like a simpler version of an Excel file. Flat files, they cannot create relationships between different sets of information. Essentially, they're standalone collections of records. So it's there, it's one file. It can do lots, but it can be also limited in some ways. So they're simple and practical, but they lack the advanced features of databases, and they're best suited for smaller one-off tasks or data transfers. And businesses have to carefully consider when flat files are appropriate and when more powerful database systems are needed. So flat files, advantages, easier to use. Most people you'll come across will have some experience with them, but their usefulness hits a point, and at that point then you start looking at other storage methods like databases. So just moving on to the next, so what we're moving into now is we're drifting away from storage and we're leaning into processing. So remember we had input at the start, storage and processing. So this is where we're going. So the next few slides just look at different processing methods. So think about everything we've looked at, how to collect information, how to store it, and now we're talking about how to process it. So one of the techniques is called data mining. And it's the process of analyzing very large data sets to uncover trends, patterns, and hidden relationships that may not be obvious at first. So why would a business need to do that? So why would you need to analyze large data sets to uncover trends, patterns, and hidden relationships? So why would somebody bother doing that? Any ideas? So why would a business conduct data mining to uncover trends, patterns, and hidden relationships? So what is the business trying to find out? They're trying to get insights, aren't they?
Yes.
Yeah. So the business is always moving from just data towards information. So there's a difference between data and information. Data is just a bunch of zeros and ones. It's all this information, but we can't make sense of it. So what these processing techniques do is they allow us to move more towards information and insights and help us make decisions. So we're constantly trying to move the data across so that we can make decisions. So unlike simple reports, which only summarize what is already known, data mining can reveal new insights that help organizations make decisions. So for example, a grocery chain or a supermarket chain might discover that sales of milk increase after it rains in smaller towns. Or a bank may find that customers with certain spending patterns are more likely to miss loan repayments. So this would be the bank or the supermarket chain digging into the information they have to try and uncover patterns. In sports, and you see this a lot, teams have used data mining to identify which college players are more likely to succeed in professional leagues. And these examples show how data mining turns stored data into actionable knowledge. Have you seen all the players? They all wear kind of GPS trackers on the backs of their jerseys.
Yes.
It's big business. So professional players, when they're playing now, literally every step, every movement is tracked. It's just really big business. And it helps the players. So every aspect, all the stats, like there are some games that are very stats driven and you can see all the scores, the percentages, the movement. So it's huge in sport. They collect all that information and then they try and get insights from it to help performance. So why do businesses use data mining? So the main purpose is prediction and decision support. So they want to have an understanding as to what they might need to do next, and they need to make decisions that are based on good information to get them there. And businesses use data mining to help them cut costs, increase revenues, gain competitive advantage. So example, supermarket, they could analyze purchase data to decide which products to stock and how to adjust prices on certain days. And online platforms use it to recommend movies, music, or products based on past choices. You know, when you go into Netflix and it recommends something to watch, it says, we think you'll like this. And that's based on your past viewing history. So that is basically data mining and data analysis running in the background on the Netflix cloud. And it's trying to get you to stay on the platform as much as possible. And those recommendation engines, they run on lots of, if you go to an e-commerce site, if you go to Amazon, if you go to Shein, if you go to all these sort of websites, they all have recommendation and based on what you've looked at and what you've bought. Banks apply data mining and analysis to assess risk. And in every case, data mining is doing work that would be impossible for a human alone because the amount of data is too vast. Instead, computers shift through the information looking for patterns and they want to present useful results that guide action. So remember, we're going from here, which is just this big bubble of big data. We're conducting data mining and then usually we're presenting it. So we're bundling it into a way we can understand. And a lot of the time for people, that can be things like a dashboard or a report. So a data dashboard. So this type of thing, where all the information across your business comes in and you can look at it and you can understand it because you can see, let me see, you can see on this, you can see this sort of progression over time. Is it going up? Is it increasing? Is it decreasing? But just prior to that visualization is your sort of data mining. And this, it's a path that the data follows. So let's just look at quickly at data mining, some of the processes and techniques. So if we start over here, so generally three sort of high-level stages. So the first stage, exploration, and that involves preparing the data by cleaning it, transforming it into a consistent format, and then you select which parts are relevant or useful for the analysis. And then the second stage is what they call model building and validation. And this tests different predictive models to see which works best. Techniques here could include boosting or bagging, which may be used to compare models and ensure reliable results. And then the third stage is when you put it to use, that's called deployment. And this is where you use the model you've created to help make predictions or estimates. Example, a retailer might use the deployed model to predict which customers are likely to respond to a discount campaign. And these steps show how raw data can be transformed into meaningful prediction. So generally these sort of steps, you're going around in this sort of cycle where you're entering the data here, you're preparing it, you're modeling it, and then you're using it. And it goes around and around in a kind of a data cycle. So that's data mining. And then we have just a couple of slides left. We'll try and get through them all. We have another thing, decision support systems. And these are all, remember, processing systems or processing techniques. A decision support system, this helps managers and employees make informed choices, but it doesn't make the decision itself, but it provides the relevant data, models, and analysis so the users can choose the best option. So this is where the computer system helps the person to make the decision. It supports their decision making. And DSS systems rely on information from internal sources, external sources, so all the information that the business has available. And they're particularly valuable for complex or unstructured decisions where no single answer exists. DSS present information in clear, user-friendly ways, dashboards, reports, interactive charts, those type of things. So DSS systems. So they're a type of processing system. They're built on databases and data warehouses, and they often use data mining to reveal trends or make predictions. They can be model-driven or data-driven, and this flexibility allows organizations to react quickly to changing conditions. So some examples, like this one over here. Airlines. So the airline is pulling in data, weather data that it has available, passenger information, flight information, all the information it's pulling in together, and they're planning safe journeys based on that. Healthcare providers, they use DSS systems to support diagnosis and treatment, all the different things, they feed them all in together to try and come up with the results. Retailers use it to guide stock pricing, that type of thing. In every case, DSS systems connect stored data with processing tools to deliver insights that directly support decision making. So we have data mining, decision support systems, and then just for the last 5 minutes, AI systems. So again, these are all systems to help with data processing. So remember our chain: input, processing, storage, output. So we're still in processing now. So AI refers to computer systems that perform tasks normally requiring human intelligence, such as recognizing patterns, making predictions, solving problems, understanding language, that type of thing. So early AI systems included expert systems, which gave advice similar to a human expert, helping businesses make decisions. So they were very narrow. You might have a computer system that was an expert on one particular thing because you'd fed in the rules to it and everything it needed to know, and then it could give you advice based on that limited domain. So another key development has been neural networks. These have been inspired how the way the human brain works. And these power applications such as medical image analysis, voice assistance, biometric recognition, all these things. Robotics, which we looked at briefly, I think, in the first class, it's another important area. And the robots are machines programmed, and they can sense and respond to physical environments. And today, AI, it's used widely across healthcare, finance, customer service, transport, and everyday tools like search engines and chatbots. So modern AI uses techniques such as machine learning. So just highlight that. And that's where computers improve automatically by learning from data. And you also have deep learning. These are just different sorts of techniques. Multi-layered neural networks. So the neural network is a computer system modeled on how the brain works. A key method is reinforcement learning, where a computer learns by trial and error to achieve a goal. So what they do is the computer tries and it gets a result. And if the result is not successful, it fails, it tries again, but it remembers what it did the first time. And it repeats and it repeats and it repeats. And you have areas like that. Use self-driving cars, industrial robots. So another one is generative AI. So something like ChatGPT or Copilot would be generative AI. And that's an AI that can create new content such as text, images, synthetic medical data, so not real medical data. Other examples include creating lifelike images from prompts, generating music, producing personalized educational materials. I see there's a tutor mode in ChatGPT now where you feed in your curriculum and then it can test you on it. AI is also critical in fraud detection, climate modeling, and personalized recommendations. So things like that we spoke about, Netflix and Spotify, and what to watch or what to listen next. And then while predictions about merging humans and remain machines, so this kind of Terminator thing, you hear a lot of scaremongering about AI and about this sort of cyborg computer age. It's largely speculative at the moment, but AI continues to grow rapidly and influence nearly every sector of business today. That's the last slide for today. Remember, we covered a lot of ground. We went through cloud computing. These are different, think of it, databases in the cloud managed by somebody else. Usually a database you'll have to manage yourself, generally used by bigger businesses. You have different types of databases. You have data warehouses, you have RDMS systems which link the different things together. You have different types. You have flat files. So flat files, different, again, much smaller in scale. You're probably more used to these. A single file that you work on, you process the file and you save it back to where you found it, or you send it to somebody. The different types. So these first file, all these, everything here from the start, right, to flat files is to do with storage, really. And then we move into processing. Then we're talking about data mining, why businesses use data mining. And it's to move from just having a jumble of stuff, information, a jumble of data over to information. And that's really important because that's the journey. We looked at different techniques, decision support systems, how they can be used, some of the use cases for them. And then towards the end, we looked at AI. But these are all ways to process information to guide you and to help you or the business move forward. That's it for today. I'll pop the slides over to the college and look forward to chatting with you soon. Thank you for joining me today. Please go through the lessons in your own time. Try and understand them as best you can. Like I said, always come to class with a couple of questions, or if you need to. That's not a problem. Have a great day or evening, and I will chat to you soon.
Thank
Thank
you.
you, Alan.
Thank
Thank you.
you. Have a
Bye-bye.
nice day.
You too. Bye-bye.